Hey everyone, and welcome. Today, we are diving into a topic that is an absolute game changer for any developer: software design patterns. And look, this isn't just about boring theory. This is about learning the blueprints to write code that's cleaner, way more flexible, and just dramatically easier to maintain down the road.
So let's be honest for a second. Have you ever started a project, with beautiful, clean code, only to watch it slowly but surely descend into this tangled, spaghetti-like mess? A system that just becomes rigid, fragile, and a total nightmare to change? Yeah, if you're nodding your head right now, you are definitely not alone. But what if I told you there were proven blueprints, like battle-tested solutions that could actually prevent this from happening in the first place? Well, that's exactly what we're talking about today. There is a better way to build from the ground up.
And that's where software design patterns come into the picture. Now, I want you to think of them not as these strict, rigid rules, but as a toolkit full of brilliant, reusable solutions. These are ideas that have been refined over decades by some of the sharpest minds in our field, famously cataloged by the pioneers we all know as the Gang of Four.
So what is a design pattern really? The classic definition says it's a common, reusable solution to a problem that pops up over and over again. But here's the key. It's not a finished piece of code that you can just copy and paste. Nope. It's more like a template for how to solve a problem, a core concept that you can adapt to your own specific situation. And these patterns aren't just some vague ideas. They're actually documented with a really clear structure. Each one is broken down into 4 key parts. It's got a name, for easy reference, the specific problem it's meant to solve, the abstract solution it proposes, and just as importantly, the consequences. The trade-offs. It's basically a complete blueprint for how to implement it.
And honestly, this is the perfect analogy. Think of design patterns as a master craftsperson's toolkit, right? An architect doesn't invent a whole new way to build a window for every single house. They use proven, effective designs that they know work. In the same way, a great developer doesn't need to reinvent the wheel for every common problem. They just reach into this toolkit for the right pattern to build something elegant and robust.
Now, this toolkit isn't just a jumble of random ideas all thrown into a box. It's actually really neatly organized into categories, which helps you find exactly the tool you need for the job at hand. So these patterns are generally grouped into 3 main categories. First up, you've got creational patterns. These are all about how objects get created, which gives you a ton more flexibility in that process. Second, you've got structural patterns, and these focus on how you compose classes and objects together to form larger, more complex structures. And third, we have behavioral patterns, which are all about how objects interact and pass responsibility between each other. Okay, theory is great and all, but let's actually see these tools in action. We're going to pull 3 essential and really widely used patterns from our toolkit to see how they solve real-world problems.
First up, from the structural category, we have the facade pattern. Its official job is to provide a unified, simplified interface to a really complex subsystem. Basically, its entire purpose is to make a complicated system much, much easier to use.
And the perfect real-world example of this is a hotel concierge. Think about it. As a guest, you don't need to know the direct line to the kitchen, or the housekeeping schedule, or the valet's extension. You just make one simple request to the concierge, like, hey, I need my car and a late dinner, and they act as your single point of contact, handling all of that crazy complexity behind the scenes for you. So how does this actually translate to code? Well, you create a single facade object that gives you a clean, simple set of methods to call. When your code calls one of those methods, the facade object turns around and delegates that request to all the right parts of the complex subsystem, completely shielding your client code from all those messy implementation details. And the most important benefit here, the real magic, is that it promotes what's called weak coupling. All that means is that your main code isn't all tangled up with the complex inner workings of that subsystem. You could completely change or upgrade that entire subsystem later, and as long as that facade interface stays the same, your client code won't even notice. And that is a massive win for long-term maintainability. Next up, let's grab a tool from the behavioral category, the observer pattern. Its main goal is to set up a one-to-many relationship. So when one central object, we call it the subject, changes its state, all of its dependents, the observers, get automatically notified and updated. The perfect analogy for this is a YouTube subscription. Seriously, you are an observer. You subscribe to a channel, which is the subject. When that channel uploads a new video, which is a change in its state, you and all the other subscribers are automatically notified. You don't have to keep refreshing the channel page yourself, right? The update just comes to you.
And the mechanism behind it is just as straightforward. Observer objects basically just register themselves with a subject. Then, when something important happens to that subject, it just loops through its list of registered observers and calls an update method on each one. It's simple, it's clean, and it's all automated.
So what's the big deal here? Well, the key consequence is that this pattern supports broadcast communication. The subject doesn't need to know anything specific about its observers, other than the fact that they're listening. It can just blast out a notification to many different types of objects all at once without being tightly coupled to any of them. All right, our final example from the toolkit is another awesome behavioral pattern, the strategy pattern. This one is all about giving your code options. The core idea is to define a family of related algorithms, wrap each one up, and make them completely interchangeable. This lets you swap out how something is done without changing the client code that's asking for it to be done. Just think about a GPS navigation app. You use this all the time. You put in a destination. Then you get to choose your travel strategy. Are you driving, walking, or taking public transit? The app swaps out the entire routing algorithm on the fly without changing the rest of the user interface. Each of those routing methods is a different strategy.
So how do we build this? First, you define a common interface that all your different algorithms, your strategies, are going to implement. Your main object then holds a reference to just one of these strategy objects. And here's the crucial part. You can change that reference at any time, even while the program is running, to completely change the object's behavior. And this delivers one of the most powerful benefits in all of software design. Instead of some giant, messy block of if-else statements, you could just easily exchange entire behaviors. This makes it incredibly simple to add a new strategy in the future, let's say a biking route, without modifying a single line of existing code. That is a classic example of the open-closed principle in action. Your code is open for extension, but closed for modification. Beautiful.
So we've just looked at 3 tools from this incredible toolkit, but this is about more than just learning a few clever tricks. This is really about adopting a new mindset, a blueprint for building better, more professional software. So why does all this matter so much? Well, it boils down to 4 key things. First, it gives your team a shared vocabulary. Saying, let's just use a facade here is precise, and everyone on the team instantly knows what you mean. Second, it builds in flexibility, making your code so much more adaptable to future changes. Third, it massively promotes reusability. And finally, it lets you stand on the shoulders of giants, leveraging decades of collective wisdom instead of trying to solve every single problem from scratch.
And that brings us to the end. But really, it's just the beginning of your journey with this stuff. So I'll leave you with this one question to think about. As you go back to your own projects, what recurring problem, what tangled little mess in your own code could be elegantly solved with one of these patterns? The answer to that question might just be your next big step toward becoming a master craftsperson. Thanks for tuning in.